So in this video, let's look at place value and let's try and have a really good understanding of what these numbers in front of us actually mean. So when we're writing a number, it's convention to block it into groups of three, okay? Because it's easier to say in groups of three, easier to visualize in groups of three. So this number here, if we just had the 839, that obviously is 800s and 30 and 9 units, 839. If we just had the 6 and the 4 and the 1, now it would be 641. But because we have some spaces here, we have different units. So the 1 is in the thousands column, the 4 is in the 10,000s column, and the 6 is in the 100,000s column. 641,839 up to there. And then we can go even further and have the millions column and the tens of millions column and the hundreds of millions column here at the end. 572,641,839. So we block them into threes to help us to say things, help us to visualize things. So at this point, it's probably appropriate to really consider place value and think about this scale and think about each of these columns. So if we start by thinking about our units column, right, these are just ones, right? Okay, if we think about our tens column, well, of course, there will be 10 ones. Okay, so when I have a number like 24, I'm thinking 2 lots of 10, right? And 4 lots of 1, 24. And it's quite simple if we know our value system to link the words to the numbers. So A is 24, 86, 19, and now we're into the hundreds now, 120, so we'll introduce something else, the hundreds column there. So 120 is going to be a 1 in the hundreds column and a 2 in the tens column, and there's no units there, 120. 304, well, there's 300s as it's stated. There's no tens in this time, there's just the 4 units, 304. When we get to the thousands, this means another column, okay? So thousands, we're up now into the next sort of section of threes. So we have 1,000. There's no hundreds mentioned, and we have a 26. So we'll write it like that, 1,026. So then we get on to even more. So we've got the tens of thousands and the hundreds of thousands, right? And then past that block of 3, we're into the millions. So in G, we have 3,400,000. So 4 lots of 100,000s. And we don't have anything else in any of these columns. So 3,400,000 is going to look like this. 1,005, so we have 1 in the thousands and just the 5. So we fill out that. There's no hundreds, no tens, just the 5. 1,005 looks like that. Okay, now we can use this and we can place things in order based on this sort of ranking system, because clearly the further to the left we go, the more value all the numbers take. So if I want to think about writing numbers in size order, a good idea would be to write them in a place value table. So taking the numbers in part A and writing them out underneath each other, we're going to have 147, 222, 316, 47, 32, and 1,004. So let's consider this in a table, and we've got units, tens, hundreds, and thousands. So we're always going to start and see if we're writing in size order with the smallest first, okay, let's concentrate on things that don't have any thousands and any hundreds. They're going to be the smallest. So we have a 47 and we have a 32. So we look at those and to determine which is the smallest, well, which has the least in the tens column, because clearly that's going to be smaller. And of course, it's the 32. So let's make a note. So the first number, the smallest number, is going to be 32, and the only other number with no hundreds is going to be 47. So those are our first two in our list. So then continuing on from there, which is the next number? Well, clearly the 1004 has a number in the thousands column, so it can't be that one. So the only numbers that don't have any thousands is 147, 222, and 316. So we look and see how many hundreds and which one has the lowest amount of hundreds, and clearly it's going to be the 147. That's got the smallest amount of hundreds, it's only got one. The next one up from there is going to be 222, because it's only got 200s compared to the 3 in the 316. So we'll say this is the fourth number, this is the fifth number, and then let's put that one with the thousands. That's got to be the biggest one. That's going to be our sixth number. So writing this out in order, we're going to have we're going to have 32, 47, 147, 222, 316, 1004. Now, if you are watching this video and want to have some practice, I'd like you to pause it now and see if you can organize sections B and section C so that they are in order, starting with the smallest. Okay, hopefully you've had a chance to do that. Let's see if we can work out these answers. So starting with this, we're going to do B first, starting with the smallest. It's going to be 621. Then we're going to have 1,471. Then we're going to have 1,472. Then we have 3,416. 3,813, 15,721. So that's the correct order for B. We move on now and have a look at C. Starting from the smallest, we should start with 3,000. Then it's 6,000. Then it's 30,000. Then it's 60,000. And finally, the largest number there is 4 million. And those are the answers. Okay, now we can carry this on and introduce decimals as well, because we can get smaller than units. If we go back to our place value table, we can add in partial units, so like tenths. So that's a 10 tenths make up a whole unit. And we can go back even further and have hundredths as well. And 100 hundredths are going to make that whole unit, right? So we can carry this down in both directions. Now, these are far easier to say. We don't need to remember anything too much. It works in exactly the same way as whole units, but kind of opposite. So 1.743 means 1 unit, 7 tenths, 4 hundredths, and 3 thousandths. Okay, so we can go back and do exactly the same thing by organizing numbers and looking at their place value and how many units are in each one of those place value sort of holders. So let's do the same thing with these numbers here. So we don't have any units this time, but let's put the units column in and a decimal point, and let's think about tenths, hundredths, and thousandths, and see what happens. And we'll make sure we line up our decimal place in every one of these examples in exactly the same place. Okay, so let's write these in. So we're going to have 0.5, 0.9, 0.905, 0.59, 0.509, 0.6, and 0.9. And let's just continue this line on. Let's make sure we put that decimal place in exactly the right place so we can see where we are. Now, if we start here, we are looking to write these numbers again from the smallest first. So the smallest numbers are going to have the least amount of tenths because the tenths are the biggest unit we've got to compare these against. So if I'm looking for the smallest numbers, clearly it could be this one, could be this one, or it could be this one, because they have the smallest amount of tenths in. So to compare these again to each other, we look to see how many is in the hundredths. Well, both 0.5 and 0.509, well, these two, well, these have nothing in there, so they're going to be in competition for being the smallest. The 0.59 is a little bit bigger. It's got 9 hundredths. So we look then to the thousandths column. Well, clearly 0.509 has a 9 in the thousandths column, so it's bigger than the 0.5 that doesn't. So our smallest number is going to be 0.5. Our second smallest number is going to be 0.509. And our third smallest number, therefore, is going to be 0.59. So moving up from there, we go back to the tenths column and we see, well, what is the next smallest? And straight away, there's only one of them. It's going to be 0.6. It's got a 6 there, and the other 3 all have 9s there. So now moving on to those ones with the 9. So we need to compare these values to see which is going to be the smallest. So we move up to the hundredths column. Now, it's got to be 0.905 or 0.9 because they both have no values in the hundredths column. So we move on again, and it's that 0.9 that has nothing in that thousandths column to compare against the 5 in the thousandths column. So this one has to be the next smallest. Then we've got that one there, and finally we've got the 0.95, which is the biggest one because it's got those 5 hundredths. So writing these out from smallest to biggest, we're going to have 0.5, 0.509, 0.59, we're going to have 0.6, following 0.6, we're going to have 0.9, then we've got 0.905, and then finally we've got 0.95. So that's how we're going to order numbers in that way. Now let's do a little follow-up question. That's going to be a little challenging. So what is the largest possible number you can make using each of these digits only once? And we've got a 4, a 6, a 3, a 2, and an 8. So if we want to make the largest possible number, we want to make sure that the big number takes over as much as possible. And if we've got 5 numbers, well, we're going to have units, we're going to have tens, we're going to have hundreds, thousands, and we're going to have tens of thousands. So we're going to want to choose that 8 to be in the 10,000s column to maximize it, to make sure it's worth as many as possible. We're going to need to do the next biggest number in the next most, I'll use the word dominant place value, which gives us the most value for our money, right? Okay, so that we're going to place the 6 there in the thousandths. We're going to have the 4 in the hundredths, and we're going to have the 3 in the tens and the 2 in the units. The smallest value is going to go in the smallest place value marker position. So our largest possible value for A is going to be 86,432. Now, if we were going to work out the smallest possible value, we're going to want to have the other way around, aren't we? We're going to make things as small as possible. So let's have the minimum possible tens of thousands, which means placing the 2 there. And then the smallest amount of thousands left over means putting the 3 in the thousandths column, and so on and so on and so on. So we're going to have the smallest number we can make being 23,468. What do we notice about the order of the digits in your answer? Well, of course, they're reversed, aren't they? In order to make the smallest, we're going to reverse the values that created the biggest. How do the answers change if we add a 0 as well? Well, let's consider the biggest value. Well, of course, if I wanted to have a 0 as well, the largest possible, so it would be 864320. We want to make sure that we put the 0 right there at the back because it's worth the least. So we'll include that as units. If we wanted to think about the smallest number, well, maybe we wouldn't even use that 0. We'd place it there at the beginning and it wouldn't even affect anything in terms of the value, right? Now, if we were arguing, well, perhaps that 0 actually should be included in the number, then we would have to put it after the 2 like this. So if we were considering that particular scenario and our parameters change slightly, then perhaps that would be the solution.